Hello Year 12 single mathematicians, just going to continue with the Year 2 content. We're on 1.3 partial fractions. I'm going to call this partial fractions part 1 because there's going to be multiple parts to this. The main objective today is to be able to reverse the process of adding or subtracting algebraic fractions. So you may remember from last time we did a question which looks something similar to this, and if you were going from left to right, that process is called simplifying, and the main thing for today is actually coming up with a method to reverse that process, and going in the opposite direction is called splitting into partial fractions. And it's going from that right to left is how we're going to approach today. So there are multiple types of partial fractions. So we're going to start off with type 1, which always look like this. So it's exactly the same as the thing above. You have the simplified version, which has got two brackets on the denominator, or two factors. Okay, they call it two linear factors on the denominator. That's type 1, and you kind of guess what the answer is going to look like. So based on above, the things you can guess easily is what these denominators would be. So we just say that this is probably from an x plus a and an x plus b. Just take these two denominators. It's impossible to tell what the numerators are going to be, so we just give them letters a and b, and we don't know whether it's a plus or minus in between, so we just say it's a plus, and then the constant b would be negative if we had to subtract. So the main other use is rather than an equal sign for these, technically I should use the identity symbol, because left hand side is identical to the right hand side. But yeah, you've got this type 1, some simplified fraction, and you predict that it splits up into this, and that's the main thing you've got to remember today is kind of guessing what the answer is going to look like, and that should be a relatively intuitive guess. So let's do one with actual numbers in there now as well as algebra. So firstly, the question will look like this. You've got to split a simplified fraction into partial fractions. So you would identify there's type 1, got two linear factors on the denominator. So that would mean that 6x minus 2 over x minus 3 x plus 1 would split up into, you know what the denominators would be, but you have no idea what the numerators would be, so you just call them a and b. And again, you should technically use the identity symbol. Now your job is to find out what those a and b values are, and many ways to do this. The best way to do this is actually effectively work from right to left and pick on the side which we were doing last time, which was actually simplifying fractions. So you actually simplify the right hand side by writing as a common denominator, but the common denominator is obvious now because it's already on the left. So 6x minus 2 over x minus 3 x plus 1. Again, you're going to write it over a common denominator of x minus 3 x plus 1. What would you times the first numerator by? Hopefully you'll agree x plus 1, and the second numerator, hopefully you'll agree, x minus 3. And then again, this is, you need to find these a and b values. So the next potential step is to get rid of these denominators because they are equivalent to each other. So this is effectively saying 6x subtract 2 needs to be identical to a brackets x plus 1 plus b brackets x minus 3. Now, at the moment, there are lots of letters and you have to find a and b, and it's quite tricky to do so. But remind yourself, for identity, that means this is true for every single value of x. Okay, so this would have to be true for every single value of x. Now you've got two unknowns. Normally, when you've got two unknowns, you'd have two equations with two unknowns and you would solve them simultaneously. And you can generate two equations with two unknowns by picking random values of x. You could pick two random values of x, which it would end up with two equations, and because it's an identity, they would have to be true, and you could solve those two equations and get a value for a and b, and it doesn't matter which values of x you pick, you always get the same two values for a and b. Now, there are two clever values of x to find, or to pick, to make the equations very easy. So the first value I would pick is x is negative 1. Let's see what happens when I choose x is negative 1. I get 6 times negative 1 subtract 2 would have to be equal to. Now this first term, if I substitute negative 1 into this bracket, that bracket goes to 0 and that disappears. I eliminate the letter a. And I'm left with substituting minus 1 into this. It'd be minus 4b. And rather than have simultaneous equations, I get one equation with one unknown, which is even better than simultaneous equations. So this would be negative 8 is equal to negative 4b, which gives b is equal to 2. And then again, pick another clever value of x, or the other clever value of xb. Hopefully you would agree is 3. And you get 6 times 3 subtract 2 is equal to a. Substitute 3 into this, you get 4a. But if you substitute 3 into this, it actually goes to 0. Which again is one equation now with one unknown instead of two equations, two unknowns. This would simplify to 16 to give you a is 4. And now I predicted that the answer would be a over x minus 3 plus b over x plus 1 for some values of a and b. And now I've worked out the values of a and b, and I've successfully reversed the partial fractions into partial fractions. So that first line, I just rewrite it 6x minus 2 over x minus 3 x plus 1 comes from the partial fractions 4 over x minus 3 plus 2 over x plus 1, and that would be your final answer. The questions I would like you to complete are on page 11 in the textbook, and we are going to try question 1, first column, question 2 and question 3. That would be it.